Hello everyone, my name is Tom Hardy and I'm one of the technical trainers here at Allied Air. This is the video series on error code troubleshooting for the 4DHV mini split series. In this video we are going to be troubleshooting the P0 code, so the error code P0. That is related to the IPM malfunction or the IGBT. The IPM is going to be your inverter power module. IGBT is your insulated gate bipolar transducers. All right, so we're going to explain how to troubleshoot these, or how to check them to see which part is the problem. Now, keep in mind the unit that I'm working with does not have a current code, does not have any errors, so what you're going to see is you're going to see your target values. Also on this one, it is a 115 volt unit, so take that into consideration when referencing my voltages to yours. If you have a 240 volt unit, it's going to be a bit higher. Alrighty, so let's go ahead and get started with this. Okay, now that we've got the power back on, we are in standby mode. As you can tell, we've got this access here. So what we need to do is we need to trace the power wires that come in. We're going to note that on my system it's 115 volts. So we're going to go line to neutral and we're going to check the AC voltage and we're going to make note of that. Now, be very careful because we are live on this unit, so we do have high voltage AC and high voltage DC within this power. So we're going to go ahead and just check neutral to L1, and we've got 123 volts. We can also do the same thing down to ground. We've got 123 volts also. So now what does that do? That gives us our basis for our measurement, because now we're going to be checking our capacitors. When we check our capacitors, we're going to note this. We got to be between 120 and 140% of our AC power is going to be our DC power on our capacitors. This is checking the IPM on this. All right, so we're going to check the capacitors. That's going to give us our IPM check. So what are we going to be looking for? Well, once again, we're going to take the incoming voltage, and we noted that voltage be 128-ish. We're going to test the capacitors. Now, what's nice about testing the capacitors is they're marked. All right, so right on the other side of this circle is that capacitor itself. Now, we're going to have super high direct voltage, so that's going to DC voltage, and we're going to be at 1.4 of the value of incoming as our goal. So what we're going to do is we're going to note here, we have to be positive and negative. We have to have polarity correct. We can see here is a plus, and here is a negative. Over here, this is a negative, this is a plus, and here, this is a plus, and this is a negative. So we want to go on those solder joints. So let's pick this one first. Alrighty. And that's 170.5. So that does fall within our range. Alright, so we'll go to the next one here. Okay, the other thing we need to check on this with the P0 code is your IGBTs. Now that's your insulated gate bipolar transducers. So to check that, we want to make sure we remove power to the unit. We want to wait 15 minutes so that our capacitors can discharge. Now what we're going to do is we're going to go ahead and do a test to make sure. So I am checking from L1 to neutral. Being that this is a 115 volt unit, regularly if it's a 230 volt unit, you're going to go from L1 to L2. And obviously, as we can see here, we're going to put this on the AC voltage. We don't have anything. Then we're going to do a double check. We're going to flip it over to DC voltage. We're going to check our capacitors. And you can see we dropped down. We're at 9.3 volts. So they're discharged enough for us to go ahead and do this test. Now what we're going to do is we're going to go ahead and flip it over to ohms. We're going to check it on mega ohms. We're going to take our red and we're going to bury that down on the positive side of one of our capacitors. Then what we're going to do is we're going to locate the UVW that goes to our compressor. Now you can either use your schematogram or your wiring diagram to find it, to see where that's at, or you can take the board over and flip it over, or you can actually look and see what you've got. So we've got 3 here, which is going to signify our UVW on this, but this goes to our fan, because when we look underneath of it, it hooks up to this wire here, which goes over to our fan. Now, I did some checking. This right here, this patch is going to be the UVW for our compressor. So we're simply going to go to each one with our negative lead. So we're on the positive side over here with our capacitor, and over here we're going to go to the negative, to our UVW. So we got 7.18, 7.18, and 7.18. That means that the gates are good on that end. Now we're going to flip it over. We're going to go to the negative side. We're going to use our negative onto a capacitor on the negative, and we're going to check. We got 7.16, 7.17, 7.17. So that means that those are good also. So if this was a true error that we had in this board, then it would be that would be the problem. We would see an irregular readings either on our capacitors, which means that the power module is burnt out, or it would be with our gates, which means that they are burnt out. They're thermally protected and they're opened up. At that point, if they're opened up, we're going to let this thing cool down for a couple of hours, put it back into service and see if it takes back off. If it doesn't, we're going to go simply replace the board on this series. Thank you for watching this video. Hopefully you found all the information that you needed and it helped you solve your problem. For any other additional problems on this series or any other Allied Air product, please check into Allied Air Academy and to get all the videos that you need. If it's not there, drop us a line, let us know, we'll create one for you. Thank you. Have a great day.